Okay, we are doing chapter 3.1, open sentences in two variables. And I wrote a lot of this lesson out ahead of time, so you're definitely going to want to pause as I go through this stuff to catch up on the writing. Example number 1, we are going to solve this equation right here. And it says the domain of x is, and it gives you 1, 0, and negative 2. All that means is that you are going to plug in 1 where you have an x, 0, and negative 2. So you're going to solve when x is 1, what is y? When 0 is x, what is y? When negative 2 is x, what is y? And so on. So if I plug in 1 here and I solve for y, I have 3 plus 2y equals 8. I would subtract 3. I have 2y equals 5, and so y would equal 5 halves. So when you write your answer, you would write your answer, and I'll just show my work here. When you write your answer, you can write your answer as a point. So if you remember, points are x comma y. So if I have x was 1, I'd plug in 1 for x, and when I solved, I got y was 5 over 2. And you would want to leave it as an improper fraction. I don't want decimals or anything like that. Then I could solve the next one, and I'd plug in 0. And I'd solve for y. I would get 0 plus 2y equals 8. Divide by 2, y equals 4. And so my point would be 0, 4. And then I could plug in negative 2. And I got negative 6 plus 2y equals 8. And I would add 6 to the other side. 2y equals 8 plus 6 is 14. Divide by 2, y equals 7. So your point would be negative 2 comma 7. And that would be your answer for example number 1. Sometimes, for example number 2, it will give you, instead of saying what the domain is, it will give you a point and it will want you to find the missing piece. So in this case, it gave you what x is. So all you'd have to do is plug in x to find what y would be. 4 times 2 is 8. Subtract 8 to the other side. 12 minus 8 is 4 divided by 3. You would get y equals 4/3. And then you plug in your 4/3 here, and this would be your answer. Example number 3 through, I think, 5, we are going to be looking at page 105, the word problems, 2 through 6 even. So make sure you're following along in the book on page 105. Number 2 says that Bruce, an appliance salesman, earns a commission of $50 for each washing machine he sells. So I made X the number of washing machines. And $100 for each refrigerator. So I wrote, have Y for the number of refrigerators. Last month he earned $500 in commissions. Find all possibilities for the number of each kind of appliance he could have sold. So I have to write an equation. I know that each washing machine that he sells, he gets $50. So I would have to multiply $50 times how many he sold, and add that to $100 for how much he makes selling refrigerators, times the number of refrigerators to equal 500. And now I could find the possible combinations of how many washing machines he could sell to get $500 and how many refrigerators he'd have to sell to get $500. I'm going to rewrite my equation, and I'm going to solve for x. So I'm going to subtract 100y over to the other side. And I'd have 50x equals 500 minus 100y. And I would divide everything by 50. So my final equation, I'm going to write right here, is x equals 50 goes into 500 10 times, into 100 twice. So now I'm going to highlight it. I am using this to find what my possibilities for x and y are. And you'll find out when it's easier to solve for one of the variables by itself by rewriting the equation, because it's easier to simplify and find out what x and y are. The only way you can do this, because you have two variables, is to plug in numbers and guess and test to see what you get. So I'm going to try plugging in 0 for the number of refrigerators. So let's say he sold 0. Sorry, I had to quick pause, so I forgot what I said. But we are going to plug in 0 for 0 refrigerators and see how many washing machines we could get. So when I plug in 0, and I'm using this equation, I would do I would do -2 times 0 is 0. And just 10 minus 0 is 10. So you could sell 10 washing machines and 0 refrigerators. Then I'll try plugging in 1. When I plug in 1 and I solve for x into this equation, I end up getting 8. And I'm not going to show my work because I think you guys can plug in for y and solve on your own. I think you're really good at that after watching or after seeing the chapter 1 scores. Number 2, let's say you sold 2 refrigerators. If you plug in 2 here, you will get 6. If you plug in 3, you should get 4. If you plug in 4, you will get 2. And when you plug in 5, you will get 0. And you know that you can stop, because if you plug in 6, and I'll show you, if you plug a 6 in here and you have -2 times 6, that's -12. And 10 minus 12 is a negative number. So you know that you are finished, and these are your possible combinations. Okay? And that is your answers. Let's look at number 4. It says Kimberly has $1.95 in dimes and quarters. Find all possibilities for the number of each type of coin she could have. So I have x equaling the number of dimes and y equaling the number of quarters. And I have to put the dollar or value amount in front of the dime. And so when I multiply how many dimes I have to multiply it by 10 cents to get how much money I have. So I have 10 cents times the number of dimes, plus quarters are 25 cents. So I'm going to have 0.25 times the number of quarters. And it says that she has $1.95, and it wants to know how many combinations of dimes and quarters she could have. So I'm going to make this easier on myself, and I'm going to move the decimal over twice. I have 10x plus 25y equals 195. And now I'm going to solve for x again, so I'm going to have 10x equals 195 minus 25y. And then I'm going to divide by 10. And since 10 doesn't go into both of them evenly, I'm not going to simplify this. I'm just going to leave it as x equals 195 minus 25y over 10. And this is the equation we're going to use to plug in to find out the possible combinations of dimes and quarters. And it says that she has dimes and quarters, so we're not going to use 0 because we're assuming she at least has one of each kind. So I'm going to plug in a 1 for the number of quarters. And when I plug in 1 and I simplify this, I get 17 dimes. When I plug in 2 and I simplify this, I get 14.5. I will tell you what we're going to do with that in a second. When I plug in 3, I get 12. When I plug in 4 for y, I get 9.5. When I plug in 5, I get 7. When I plug in 6, I get 4.5. When I plug in 7, I get 2. And when I plug in 8, I will get a negative answer. So what does this mean? Well, you can't have 14.5 dimes. It doesn't make sense. So this is not an answer. You can have 12, but you can't have 9.5. You can have 7, you can't have 4.5, and you obviously can't have a negative number of dimes So this one is not an answer. And whenever you get a negative, you usually stop. So these are your answers or your combinations for the number of dimes and quarters. Last one, number 5. It's on the next page. I'm sorry, this is actually example 5, but we're looking at number 6. It says an isosceles triangle has a perimeter of 15. Find the integral possibilities for the lengths of the sides in meters. Hint, the sum of the lengths of any two sides of a triangle must exceed the third side. So, an isosceles triangle means that two sides are the same. So that's why I made these both x, because I know they're the same length. And then I have y because I don't know what y is. If I were to find the perimeter of this, I would add all my sides together and I would get 2x plus y equals my perimeter, which is 15. I want to solve for one of my variables, so I'm going to get y by itself, and I'm going to have 15 minus 2x. And this will now be my equation I look at when I'm trying to find my possible lengths for my isosceles triangle and for the base. So I'm going to start by plugging in 1 for x. Now, the hint was that the sum, let me read it so I get the wording correctly, but the sum of the lengths of any two sides of a triangle must exceed the third side. So when I multiply these two, or when I add these two together, it has to be bigger than y. So when I plug in 1 here, I know that 1 plus 1 is 2, so that's why I wrote 2x, because I'm going to times it by 2, so I add those two sides together. So I get 2, but when I solve for y, I would have 15 minus 2, which is 13, and that wouldn't work because 2 has to be bigger than the 13, so this isn't going to be an answer. But I'll keep going. So let me try 2. So that means that when I add 2 plus 2 together, I get 4. And when I plug in 2 for x, I end up getting 11. And again, 4 is not bigger than 11, so this would not be a combination. I'll try 3. I plug in 3 for x. I have 15 minus that, I get 9. And 3 plus 3 is 6. So again, 6 is not bigger than 9, so that is not a possible combination. I will try 4, which means I would get 8. When I plug in 4 for x, I end up getting 7, and now this one works. So all of these I can cross off because these don't work, but now I'm starting to get into ones that are probably going to work. 7 is less than 8, so we're okay. Let's try 5. I plug in 5 in here. I end up getting 5. And 5 plus 5 is 10, and 10 is bigger than 5, so this one works. We'll try 6. I plug in 6. When you plug in 6 for x, you end up getting 3, and 6 plus 6 is 12. 12 is bigger than 3, so we're good. Plug in 7 for x. 7 plus 7 is 14, and when you plug in for x, you end up getting 1, and 14 is bigger than 1, so we're okay. When you plug in 8, 8 plus 8 is 16, and when you plug in 8, 8 times 2 is negative 2 is negative 16, and you would get a negative answer, and that does not make sense. You can't have a negative distance. So these are your possible combinations for your length.